Okay, we're told here that the weightlifter is raising a barbell of mass 120 kilograms. Let's just represent that with that. So we've got 120 kilograms barbell. In other words, its weight is going to be 120 G newtons. So the force is on the barbell. You've got its weight acting downwards, and then the two arms, so his two arms, I'm going to draw them over here, are pushing upwards. And we have to assume there that the force that each arm is pushing upwards with is exactly the same. Now, if he's holding that stationary, it means that the forces acting upwards must equal the forces acting downwards. The forces acting upwards altogether are 2F, so that's the force on each arm is F, and that's going to equal 120 G. In other words, the force from each arm is going to be 60 G, which comes out as 588 newtons. Now, in the second part of this question, what happens now is he now increases the force. So the weight that he's lifting is still 120 G newtons, and he now exerts more force with each arm and increases the force from each arm to 700 newtons. Sorry, no, 800 newtons. So 800 newtons with each arm. In other words, the total force, that's just the same as him pushing upwards with 1600 newtons, and the weight of the barbell still acting downwards is 120 G newtons. Okay, so if we use Newton's second law, so we're now told to find the acceleration in an upwards direction. So I'm taking upwards to be positive. So I'm going to use Newton's second law in an upward direction. So forces acting upwards, 1600, acting against that, you've got the minus 120 G, negative because it's in the opposite direction. And that is going to equal the mass of the barbell multiplied by the acceleration. I'll leave you to finish that off.